Hey guys, this is a fun one. It wants us to find the area of this cartoony cloud. Now, if you want to go ahead and try to solve this on your own, then pause the video. If not, I'm going to solve it in 3, 2, and 1. So obviously this is impossible first glance, and you're kind of stupid for trying to solve it. It seems that they have supplied a hint. Let's click on it. Hint. The top, left arch, not the one that juts out on the side, more like the big one of on the left. It kind of looks like Patrick's house. The shit. I just lost my train of thought. Okay, yeah. The distance from that to the bottom one on the right, but not like the complete right or literal. Or I just don't confuse it. Just screw it. I'll just show it on the next slide. Is our hint. So let's see what they mean. Okay, we've been given the information that the distance from this one arch that looks akin to Patrick's house to this other arch that also looks similar to Patrick's house is 56 meters. However, we don't actually care about this length right now. The length that we're actually looking for is here, which we are going to aptly name x. But before we discuss why x is important, let's look at what we can do with this line. Well, when utilizing the Pythagorean theorem, we know that a squared plus b squared equals c squared. And by utilizing this simple fact that derives from the Pythagorean theorem, the Pythagorean theorem, we are able to successfully deduce that this line length is 14 meters and that this line length is 4.8 meters. And then by using the formula to find the area of a triangle, which is 1/2 times base times height, let's substitute in 4.8 for the base and 14 for the height. By multiplying this all out, we are able to see that the area of this triangle is 56 meters. Now here's where things get tricky. If we're going to want to progress in this problem, you're going to have to utilize the formula by 18th century mathematician Infrael Worstein. Infrael Worstein famously came up with the modern expression, all for one and one for all. Now this relates to math. Now by law of cohesion, we know that the area of the second triangle will be 56 muffet, which is a metric that I've not heard of, but I'm sure is very useful in countries like Europe. Now, the next formula that we're going to have to utilize is formerly known as Cauchy-Magellan's eighth. Cauchy-Magellan's eighth. Cauchy-Magellan's eighth. What Cauchy-Magellan's eighth basically states, it opens mathematics up to the world of coagulation. So by taking a certain value from one sum and stretching that value out, and making sure to stretch out that wall by a specific angle, which, just thinking about, I think that's 56 here, degrees. I believe, according to Cauchy-Magellan rules, would mean you are able to calculate the length of this specific line, which means that the line's length is 56 meters. Now, let's remind ourselves that we're still trying to find this value x. So the next technique that we employ to get this length to match up to x is actually another Cauchy-Magellan work. Yes, this is the second formula, which was created by 18th century philosopher and mathematician Cauchy-Magellan. Kishmageli. Now, in this specific one, we're going to have to use this formula. Basically, what this formula means is that it combines coagulation and duplication. So we can take this length and we can coagulate and duplicate over and over and over again until it eventually matches up to x, making it one big equal sign, which is good. Actually, fun fact about this little theorem here. This is Kishmageli's first words. He came out the gate swinging, some may say, and by gate I mean his mother's reproductive system. Turns out he invented and taught himself calculus 1, 2, and 3 while inside of the womb of his mother. But anyway, enough yammering. So by utilizing the first words of Kishmageli, which is this theorem, we are able to duplicate and coagulate, which is that slight shift, over and over, again, utilizing this specific theorem. So with our next, and we're using this, by the way. So we're gonna start duplicating by using Kishmageli. We're gonna keep repeating this process, which utilizes this specific thing. Okay, we're gonna keep going that and do that. Kishmageli. And then we're going to keep doing that. And again, by utilizing this, eventually we're going to, if you see there, we're going to have a touchdown. We're going to reach x. And since the line for Kishmageli's stick and x is about parallel, we can solve this problem with some basic algebra. So we're going to use the equation that x equals 56 minus 56 minus x. This reduces down to x equals 56 minus 56 plus x. With these two 56s canceling each other out, this simplifies down to x equals x, which makes it about 56 meters.